And why do we care? Absolute value of a number or an expression or something else. Okay, one way to define it is to say, can be defined as the principal square root of the square of a number. Have a look. 6 could also be written as the square root of 36, right? And then you might have memories of, remember how when you take the square root of something, well, you can say it's plus or minus 6. Yeah, okay. That's basically what we're saying. Because if you put in minus 6 squared, well, when you square it, it now becomes positive. Okay, there's two options here. So that's the absolute value. Now, I don't know if that's as helpful as this. Here's another way to define it. The absolute value of a number can be regarded as the distance from 0 on a number line. Okay, so 6, here it is. How many units away from 0 is it? Well, 6. Same thing with minus 6. It's also 6 units away from 0. Okay? That's a better way to think about it. That's it. Really, that's absolute value. Okay? That's what it is. I can get into some physics stuff and start talking about, well, if I walk this way 10 paces, and if I take this as a positive direction, then if I turn around and go the opposite way, well, if that was positive, this has got to be negative. And I can do another 10 paces. Okay? The total distance was 20 paces, but it makes sense to think of, I'm right back where I started. So essentially, I didn't go anywhere. So then we have this notion of, because I'm taking the direction into account, my total displacement is 0. Okay? Distance is 20, 10 and 10, but my displacement is 0. Okay? So if I'm over here to start with, if I haven't gone in the positive direction, then why would I take this as a negative direction? When I drive from Kamloops to school, it's about 50 kilometers. When I go back home, I don't say I went negative 50 kilometers, right? I just say I went another 50 kilometers. Okay, so I would just take the absolute value of negative 50, just make it positive. Just say, this is negative 6 units away from 0. You know what? I just want a distance here. Let's not get complicated. Let's just call it 6. Okay? That's what we mean when we say absolute value. We don't want the negative. It will never be negative. Okay? The absolute value of a number is going to be positive. All right. This is the symbol for absolute value. These two funky lines. Okay? That says the absolute value of x. And you do have this function in your calculator. Well, I'll show you at some point. Okay? So this is absolute value of 3. Evaluate. Well, what do you do? Again, think. How far away from 0 is 3? That's the thinking. It's 3 units away. Okay? That's it. If something's positive, the absolute value has no meaning. It doesn't make any difference at all. It only has meaning when something's negative. How far away from 0 is negative 3? 3 units. Okay? That's all it is. Now you got to think bed mass. This says the absolute value of 8. How far away from 0 is that? 8 units. But we have a minus in front. So the answer to that thing is minus 8. Okay? Think bed mass. Or PEMDAS if you're from Belgium. Or some other strange letters when you don't have brackets and parentheses. Anyway. All right. A little more involved. What's the absolute value of negative 8? It's 8 units away from 0. Okay? And then I have this minus out in front. Okay? So I get the same thing. Just like 3 is the same as minus 3, minus the absolute value of 8 is the same as minus the absolute value of minus 8. Okay? How far is negative 7 away from 0? 7 units. How far is 7 away from 0? 7 units. What's 7 and 7? 14. Okay? So here, like, these aren't brackets, so I'm not going to call them brackets, but as far as BEDMAS goes, you can consider them like brackets. That says what's the absolute value of 1 take away 5. So do 1 take away 5 first. That's the absolute value of negative 4. Okay? How far away is negative 4 from 0? 4 units. All right? So another way to think of this is if we had a whole bunch of brackets, you know, with exponents, like in grade 10, I probably told you something like work from the inside out. Okay? If that's helpful, then do the same thinking. What's the square root of 81? So this is the same as minus the absolute value of minus 9. How far away is negative 9 from 0? 9 units, so that's minus 9. All right? So those are just some simple little operations, okay? Explaining absolute value, just keep thinking of this number line, okay? That's all it means. We're going to do more complicated things, though, of course. Investigating this function, f of x is the absolute value of x. Now, x here isn't just one number like 3 or minus 3. It could be whatever the heck you put in there. Okay, so f of x, I think it might be more helpful. Let's just think of that. F of x means the output, so let's just think of it as y, okay? So, consider this function g of x is x. Well, let's just think y equals x. That's usually a little easier on our brains. Okay? Sketch and label each graph on the grid below. So let's sketch that thing. Anyone know what that looks like? You got a mental picture of y equals x graph? Yep. You kind of should. See a couple heads nodding. If not, what do you do? Well, if you got a graphing calculator, you just plug it in. But in the good old days, you would make yourself a little table, right? X. You pick some nice points for x, right? There's 5 around the origin. Let's see what's going on. You plug it in the equation and you see what the output is, what y is, okay? X is minus 2. What's y? Minus 2. Minus 1, well, it's the same thing, isn't it? These are all the same values because y is x. So 0, 0, okay? 1, 1, negative 1, negative 1. Looks like I got something like that. Okay, that's the line y is x, right? It's a 45-degree angle starting at the origin. Every value of x is equal to y. That's what it is. Okay, so there's that one. We got another function to plot. I'm going to use red. So h of x, again, let's just think of that as y. Now I want negative x. How's this one going to look different? Every value of y is now going to be the opposite sign, right? So if you like, well, let's quickly plot it. Okay, so if x is minus 2, what's minus minus 2? Positive 2. Negative, negative 1, positive 1. 0 is minus 0, that's still 0. If x is 1, y is minus 1, minus 2. Like I said, every sign here has just got the opposite thing. Okay, so 0, 0, there it is. Okay, if x is minus 2, this is positive 2. Minus 1, positive 1. If x is 1, this is minus 1, minus 2. Do you see what's going on here? All right. That's what this guy looks like. Looks like they're perpendicular, doesn't it? Okay, so that's this graph. Whoop, that's this graph. And that's that graph. Okay, why are we doing this? Well, because this might be helpful when we look at this new thing called absolute value. Consider this function. Y is the absolute value of x. Now, what absolute value? Can I ever have a negative number? No. Let's keep that in mind. Complete the table of values. Okay, x is minus 5. What's the absolute value of minus 5? How far is minus 5 away from 0 on a number line? 5 units. How far is negative 4 away from 0 on the number line? 4, 3, 2, 1, 0. The absolute value of positive 1, how far is 1 away from 0? 1, 2, 3, 4, 5. Okay? So again, if this is positive, these lines don't do anything. Okay? It only affects something when it's negative. If it's negative, it makes it positive. Okay? But let's plot this and see what's going on. I got 0, 0. X is minus 5. This is positive 5. Minus 4, positive 4. We see a bit of a pattern here. If x is 1, y is 1. 2, 2, 3, 3, 4, 4, 5, 5. Okay. Do we see any negative outputs for this graph? And that should make sense. Like I said, we shouldn't have any negatives because absolute value cannot be negative. Okay? So this was two separate functions. This is just one function. That's just y is the absolute value of x. Similarities and differences. Well, I hope you see visually. This is like just the stuff here that's in quadrant 1 and 2. Okay? Or it's this whole graph missing the negative stuff. Okay? I'm not going to write anything down there. We just want to observe, that's the similarities, that's the differences. The graph, that's this one we just did, contains two straight lines, right? This one and this one. So if you remember grade 10, when you're graphing lines, one equation is one line. You need a different equation to get a different line. So this one function, there has to be two equations here in order to graph this, right? This one and this one. That's where we're going here. State the equation of the line in quadrant 1. There's quadrant 1. What's the equation of that line? Well, let's look over here. What was this? That was the first one I graphed, right? Y equals x. So just in quadrant 1, that was the function. Like I said, it doesn't change if it's positive. It only changes if it's negative. What is this function? That's the same as this thing here, right? That is y equals minus x in quadrant 2. Okay? Everybody all right so far? Kind of, sort of. We can see from number 4 that this equation can be written in two pieces. This is essentially what you're going to do in your assignment today. Write something in two parts. Because when you take the absolute value of it, the negative parts, they all flip up and become positive. You can't have any negatives with absolute value. Okay, now it's kind of like a butterfly. All right? So, as a piecewise function, that's some weird terminology today. This is what they mean. Write it in two pieces, a piecewise function. And maybe some graphs we're going to get 3 pieces, maybe 4 pieces. All right? Today you're just going to get 2. This is the function f of x. Again, that was the absolute value of x. If x if this function was positive, if it was greater than 0, that's all this blue stuff, then I can write that as just x. Okay? And if it's negative, if x is less than 0, then it's not the original function anymore. It has to be this thing, which again was negative x. Okay? I hate scrolling up and down, but that's how we write this function as a piecewise function. We have two separate lines there, right? One line looks like that, the other one looks like this. Okay? That's how we can graph that without the absolute value part. Okay? If all you did was graph this, that's what you'd have, right? For values x equal to 0 or greater, y equals x, there's the line. For values less than 0, y is minus x, there's the line. Okay? So when they say write it as a piecewise function, in other words, we don't want the absolute value thing here. We want to be able to write that old school, grade 10. Okay? There's two separate lines. That's the same graph as that. Okay? As a piecewise function. Okay, let's look at this thing quickly. The absolute value of x minus 3. I could plot it all out again, just like I did the last one, but let's just maybe think of that. With some things that I said. Where is this thing 0? What value of x is going to make that y value 0? Yeah, we all see that, right? At x equals 3, this thing's 0. Okay? If everything is going to be positive, what do these absolute value lines do? Nothing. It only matters if it's negative. So all the values greater than 0 here, like 4, if I put 4 in, I get 4 minus 3 is 1. The absolute value of 1 is just 1. Okay? So these lines don't do anything for values that are going to make the output positive. Or if you want, I'm not going to do that, but that's exactly what I'm doing. I'm just doing it in my head. Okay? 5. If x is 5, 5 minus 3 is 2. Absolute value of positive 2, well, it's still positive 2. Do you see what's going to happen here? These only make a difference if it's negative. Now this line, x minus 3, that's what it would look like if we didn't have those funky lines there that mean absolute value. Now that they're there, what happens with those negatives? They become positive. Okay? So if x is 2, 2 minus 3 is minus 1. What's the absolute value of minus 1? Positive 1. Okay? These all become positive. And if you remember this quadratic stuff, remember this x minus p squared plus q. You remember what p did? Shifted it left or right? Is that the same graph we just did, shifted right 3 units? Yeah, it is. There's no squared here, but it's the same concept, right? Okay, it's exactly the same graph as y is the absolute value of x, shifted 1, 2, 3 units right. Okay? So anyway, there's 3 kind of ways I've been talking about it. You could just plot it and see that. You could think of shifting translations, or just kind of work it out in your head. Okay? But hopefully we all come to that same graph for that thing. Now, I want to write this as a piecewise function. How do I write this graph, which is 2 different lines, without the absolute value stuff? Okay? So it is just x minus 3 if this function is positive. Okay? If the function's positive, if I get a positive output, again, those lines mean nothing. If it's less than 0, I got to take the negative of the function. Okay, if this thing's less than 0, I just put a minus in front of it. That's all I did last time. Okay? Last time my function was just x, so I just took negative x. Now my function's x minus 3, so just put a minus in front of it. Minus x minus 3, which without the brackets, of course, is minus x plus 3. Okay? So, if you understood all that and followed it well, then this should be okay. If not, you can still kind of memorize this and get the answer. Okay? Just wait for a couple more examples. Now, we don't want where this function's greater than 0. I just want to solve this for x. Okay? This one's pretty easy, right? If x is greater than or equal to positive 3, i.e., all these values, this thing's positive, right? If x is less than 3, then the absolute value makes a difference and all these points get flipped up, become positive. Okay? That's it. That's what this thing is as a piecewise function. In 2 parts. Okay? Piecewise function. Kind of weird wording, but that's what they mean. Okay? Just a couple more. No graphs. Express this function. It's funny, I use my finger and I point like you guys can see it on my projector. Express this as a piecewise function. All right? What do we do? You don't have to graph the whole thing, guys. Here's all you do. If this thing, if the function is positive, greater than or equal to 0, then we just have the function without the lines, right? Because if it's positive, the absolute value has no meaning. Doesn't make any difference. Okay? But if this thing is negative, all we do is put a minus in front. That's it. Okay, so to answer it the way they want, f of x is both of these two pieces. So let's just simplify that down a bit. Minus 3x minus 2 if 3x is greater than or equal to minus 2 or x is greater than or equal to minus 2/3, right? Let's put that in our graphing calculator when we're done just to check it. So this here, well, x must be less than minus 2/3, right? Or just solve it again, right? 3x plus 2 less than 0 minus 2. 3x is less than minus 2/3. Okay? So let's have a lookie. 3x plus 2. That's one part of it, and the other part of it is minus 3x plus 2 brackets. Now the problem is, this doesn't show you these restrictions here, does it? Okay? It shows you all parts. But remember, absolute value, don't look at the negatives. Okay? Is it the same function if x is greater than or equal to minus 2/3? Does that look like about minus 2/3? Yeah, that's this part. Okay? And less than minus 2/3, it looks like minus that. Okay? In other words, this part of the line gets flipped up. All right? So you can kind of check it with your calculator, but like I said, absolute value, you don't have any negatives. That's it. All right? Last one, write the absolute value of that thing in piecewise function. What do we do? Okay, it's just this function if this thing is positive and it's minus this function if this thing is negative. That's it. So if minus x, well, we better write that one out. 4 minus x is greater than or equal to 0, so minus x is greater than or equal to minus 4. I want to know about x, though, not minus x. How do I make that an x? Divide by -1, or multiply both sides by -1, and when you do that, what happens? You got to flip the sign, yes. Okay? So less than or equal to 4, so this one must be greater than 4, minus 4 plus x. Okay? That's a good idea. Let's throw it in your calculator, see what it looks like, get familiar with it. So 1,325 and 9. So number 9, we haven't done this one. It's a quadratic, but it's pretty good. It'll kind of lead you through it. Try it. Let me know tomorrow if you got a question on it, okay?